Hi YouTube, this is Joe Kelton with Kelton Cutlery. You can visit me on the web, keltoncutlery.com. So we are going to continue this series on knife edge retention tips. This is going to be number 15, I think, and I think we're kind of closing on the end of this series here. The last couple of videos we've done have been on, the last one was hardness, and the one before that was to abrasion resistance. Okay, talking about carbide. We used lathe tooling kind of as an example on that. Carbide tooling versus high-speed steel tooling. There's a couple of dogs running on the loose right now. German Shepherd and I'm not really too sure what the breed of the other one is, but they're running around loose, you know, having a grand old time, driving my boys nuts. So anyway, the hardness of your blade you don't really have much control over as a consumer, and then trying to talk the factories and custom makers into changing the hardness of a particular blade, you know, that, you know, sometimes you can, sometimes you can't. In my case, you know, more than likely not. This one we're going to talk about burnt edges. Okay, now what happens here is kind of borderline, you know, a fault of the steel, or a fault of the maker, or, you know, a fault of the sharpener. You know, you never know, right? But this can affect your edge retention quite a bit, all right? And that is burnt edges. I mean, the edges aren't actually burnt, they're just overheated, okay? This typically happens in three different times, all right? One, when you make the knife, when you heat treat it, okay? Here's one of my heavy pair blanks, right? So, you know, I cut the steel out, I drilled my holes. I typically do an awful lot of stuff at full thickness, okay? I typically will not grind a bevel in and then heat treat it and then, you know, regrind the bevel. So typically most of my stuff is full thickness, okay? I mean, the stock removal stuff is. So this is 3/32, 1095. So I cut it out, I smoothed out, you know, the profile, I drilled my holes, and then I heat treated the thing, okay? Now, this knife will go through a heat cycle, or several heat cycles, to reduce the grain size, okay? And then they go through 3 quenches, because I'm a multiple quench guy, and then it'll go through 3 tempering cycles, okay? So the steel that is on the very outside, okay, the steel that gets exposed to anything over, say, 1200 degrees Fahrenheit, is going to start losing carbon. Okay, because when you heat steel to a certain temperature, it can absorb carbon or it can release carbon, depends upon the atmosphere that's inside the forge or inside the kiln, but that's kind of a story for a different day. If you are heating the blade in electric or propane, okay, chances are that you're going to get what's called decarburization. All right, now that decarburization is when that steel gives up carbon to the atmosphere. All right. So this particular knife, well, all of them, okay, once you heat treat it, when you grind the bevels in, okay, and then when you sharpen it, you have to make sure that you take off, no, I can't see on the other side, you know, have to make sure that you take off a certain amount of steel along the edge, okay, either through grinding it off or through, as you sharpen it and you create a burr, you know, removing that steel because it has been decarburized. Now that decarburized steel is not going to have as much carbon in it as the rest of the blade, and it's not going to be the same hardness as the rest of the blade, okay? Every once in a while, what'll happen is that you'll have a blade that you didn't get enough of that edge ground off to reveal good steel when you make the knife and then ship it to the customer, okay? Very, very rare, but it can happen, all right? So what will happen, the end user will experience is you'll take the knife and start using it and it'll dull really quick. And you'll be like, what on earth is wrong with this? So then you sharpen it back up and then go back to using it again and it'll dull fairly quick again. And then you sharpen it back up and then you use it again, and now all of a sudden, boy, that edge retention just goes through the roof. You're like, hey, this isn't even acting anywhere remotely like what it was the first sharpening. If that happens, chances are is that you didn't take enough steel off of the edge profile before you sharpened it after heat treat. Okay, now that same thing can happen on power sharpening equipment, all right, which is why I am so big on hand sharpening on a stone. Okay, sure, you can rough in the edge on a belt grinder or on one of them paper wheels, or whatever kind of power equipment you have, but always finish the edge on a stone. Okay, because it is very, very easy to overheat an edge on power equipment. I mean, it will happen in less than a blink of an eye, especially the guys that are sharpening really, really fast, really, really hard on really high speed equipment. Okay, now I can take a knife edge or a knife and go in there to my belt grinders, rough the edge in on, say, a 120 grit belt, okay, and then go to my variable speed belt grinder, throw a 400 grit belt on there, or a 220 grit belt, something like that, slow the speed way, way, way down, and then sharpen that knife, and then pull it right off the belt grinder and take hair, off my arm or my face, and have a good edge. But I've practiced an awful lot. I know which speeds to use, and I said variable speed belt grinder on the lowest setting with a fresh belt, and you can get away with that. Doing the same thing like on a buffing wheel with a paper disc on that thing, and then just hammering this knife out and hammering that knife out over and over and over as fast as you can. Generally, you're going to overheat edges big time, and then you're going to have to sharpen away that overheated steel, because if the second you get the steel over the tempering temperature, so like this blade right here, this is 1095, this is going to get tempered 3 times. The first time is going to be 3 hours, the second 2 times are going to be 2 hours with an hour cool down period in between them. Okay, they're going to be at roughly 350, 375 degrees, depending upon your particular tempering oven, is going to be the tempering temperature of that knife. You ever get that edge over that tempering temperature, and you're going to start softening it up, and you're going to start losing edge retention. Okay, so, and power equipment can hit that in a hurry. Another time is overheating the blade anyway. So I ran into a friend of mine who I had sold a pocket knife to a while back, and ran into him at the store, and I said, "Hey, how's that knife going?" And he pulls it out and he said, "Man, this is the best dang knife I ever had." And I'm looking at it, and from this far away I can see that there's blue and there's violet and there's all kind of colors in that blade. And I get a little bit closer and I said, "Dude, what on earth did you do to that?" And he says, "Oh, we were melting some plastic to repair something or other, and I was using my knife to weld the plastic." And I said, "Oh." I said, "How's it holding an edge?" And he says, "Great." And I said, "Oh, well, that's kind of cool." If he got it to blue, that means he got the tip of that knife, 500 degrees Fahrenheit or so. But then again, the knife wasn't sharp. It was clean, and that was kind of his deal, so I figured, let him go with it. But anytime you get that edge over the tempering temperature, the next time you're going to lose edge retention, and then when you sharpen it, you're going to have to sharpen it back to get back into good steel. So it's something that's kind of rare, but it does happen, and I'm trying to be complete on this, the edge retention or knife edge retention tips videos. So again, this is Joe Calton with Calton Cutlery. You can visit me on the web, caltoncutlery.com. Hope you enjoyed the video, and we will see you next time.